Hello, Honors Chemistry, and welcome to the Chapter 6 review, where we are going to start by refreshing our memory on all the conversions that we've learned to date, which is a significant number, and don't forget that every unit that we do will probably layer on, at least a few more conversions, right? And our list here will grow right as we progress through the year. But to date, we've learned a few, right? So we learned in Chapter 2, we learned about our SI prefixes, right? Note that those are supposed to be memorized. If you are currently realizing that yours are not memorized, like for example, when you saw micro on the quiz and you're like, oh man, you need to go refresh on those, right? It is expected that those are memorized. So we learned those SI prefixes. They were the handful of English to metric that were supposed to be memorized. So make sure you know those, right? And again, if you're like, what? Go back and look at those again. And we also talked about density, right? Where density is the relationship between mass and volume. And so it converts between those two quantities, right? And the only one you're responsible for knowing is, right, water. You should always know that the density of water is 1 gram equals 1 milliliter. So for water, 1 gram equals 1 milliliter. Always, right? And you're just supposed to know that forever, okay? In Chapter 3 and 4, in terms of conversion factors, you have your energy ones, right? So go refresh your memory on those, right? And those were just the energy units, for example. In addition, we have our Q equals MC delta T relationship, right? Where C is in units of joules per grams times degrees Celsius, right? You have your, not just your energy units, but you have your T conversions, which you should go look up because I'm thinking back to the Chapter 3 and 4 test. I think a lot of people missed some of those questions also. So make sure you remember your temperature conversions. But we have our Q equals MC delta T, which is fashioned as an equation, but really C is our conversion factor there, right? And it gives us the relationship between joules, right? Measures of energy versus grams and degrees Celsius, right? Or a change in temperature. In 3 and 4, what else did we have? In terms of math, we also had our average atomic mass, or the concept of a weighted average, which is not so much a conversion, but just a math skill that we should know how to do. What else? And then in Chapter 5 and 6, right, we learn about a lot of different conversion factors, right? We have Avogadro's number, where Avogadro's number does what? Right, it converts between particles and moles, right? And note that particle is the broad term, and we should, when we hear molecule or atom or ion or, I don't know, that's all I got right now. When we hear any of those words, we should think particle, and we should think Avogadro's number is part of this process, right? We also have the concept of molar mass, right? Which converts between mass and moles of a given substance, right? And we would use the information on the periodic table to help us do that, right? Because again, that mass written at the bottom of every element, right, is the mass of one atom measured in AMU. It is the mass of a mole of atoms measured in grams, okay? So Avogadro's number converts between particles and moles. Molar mass converts between mass and moles. And we also have all of our piece versus whole conversions, right? Which are based on things like mass percent. We have our particle relationships and mole relationships. Particle, mass, and mole relationships, right? Where I can say that 1 formula unit of sodium chloride is equal to 1 ion of sodium, or that 1 molecule of carbon dioxide is equal to 2 atoms of oxygen. Or I can say that in CO2, for example, there are 44.01 grams of CO2 are equal to, say, 32 grams of oxygen, right? So all these relationships, and again, if you're like, oh, that's fuzzy, go back and look at your notes from our in-class lecture where we went over a whole bunch of these, okay? If perhaps you didn't take very good notes, I would suggest you go talk to a friend about that. All right, now, these are all the conversions that we know to date. Some of them you just have to commit to memory, right? I would say that for like the SI prefixes, you just have to memorize English to metric, you just have to memorize. Same thing with our energy and temperature conversions, right? Those are just things you commit to memory, and we will literally use those all year, okay? Then we have our other types of conversions where it's less about memorizing the conversion, but knowing what to do with it, right? So as in density gets us between mass and volume, so it allows us to convert between two different quantities, right? Q equals mc delta T, again, allows us to convert between different quantities. Same thing with Avogadro's, molar mass, right? And our piece versus whole, right? So those are different types of conversions where, again, different quantities, okay? So we need to assess what quantity we are given, what quantity is our goal, right? And figure out how to get there based on, the conversions that we know, right? So one of the ways that some people like to look at it is with the concept of a map, right? Wherein we can start with something central. And obviously, so a map is just to help you make connections, right? And not something that you're supposed to have to regurgitate every time before you solve a problem, okay? Because then it becomes like a crutch. And as we layer on more and more conversion factors, the map gets to be a mess, right? It's just something to help us visually organize our thoughts right now, right? And again, once you've seen it and thought about it and memorize what the conversion factors convert between, you should find that you don't need to doodle it for yourself every time, right? That's the goal, is that you understand the conversions and you just know how to use them. All right, so first we have the concept of a mole, right? Where a mole is just a defined number of particles or defined amount of mass, right? Based on certain constants. And so we can convert from a mole to mass using, right, we can use molar mass to get that done, right? We can convert from moles to, say, particles, where, again, particle words are like molecule, atom, ion, formula, unit, right? And we can do that using what? Right, Avogadro's number, okay? And then we can layer on other conversions, right? So from mass, we can convert to volume, right? Using what? Right, using density, right? We can convert from mass to, what else? Mass to energy or heat, right? Using our what? Right, using Q equals mc delta T, assuming we have all the information for that, right? We can even take this one step further. Like, what else have we done? We can actually get from volume to, what is it called? Dimensions, right? Where dimensions would be like the length of a side or the radius of something, right? We can use that using our volume equations, right? That you guys know, right? Like the volume of a cube is length cubed, or the volume of a sphere is V equals 4/3 pi r cubed, right? Etc. So anyway, these are all the conversions we know to date. So what this means is, as we think about this, we can just sort of imagine, where are we starting and where are we going, right? If my given is moles and I would like to get to a volume, right? Then step one is I will use molar mass to get to mass. And once I'm at mass, I'll use density to get to volume, right? Like all those pieces are connected and I can go from one to the other, right? Likewise, if I were given dimensions, like the radius of something, and I wanted to get to the number of particles, right? Step one is I would use my volume equation to get to volume. I would use density to get to mass. I would use molar mass to get to moles. Avogadro's number would then take me to particles, right? And so this is just sort of a visual organization of all the conversion factors, again, that we have learned to date. And like I said, the goal is not that you would have to doodle this every time, because like I said, we will layer on more things as we go, right? But just sometimes it helps to see some of it written out. So then what that also means is we can tie in some other stuff, right? Like if we were given a heat and we could use Q equals mc delta T to get to mass, and then we could get to moles and particles, right? So all of these are connected. All right. So again, this is just our conversions that we know and how they are related. And that's it. Okay. So make sure you practice, because again, this just sort of connects them. And now you need to actually apply. All right. Thank you for listening. Be good, and I will see you soon. Bye.